All right, everybody. I hope your study of parametric equations and functions is going well. I want to move on into polar coordinates now and see what kind of calculus we can do with functions that are given in polar coordinates. So let's start with just a review of what we should know before we start the calculus. All right, so maybe a good place to start is just by developing what these actually are. So, Cartesian coordinates, we're used to doing that, right? We're used to taking a point and recognizing that it has an x coordinate and a y coordinate, okay? And if you want to think about kind of movement or how we get to that point, you essentially move horizontally and then vertically some prescribed distances, and that takes you to whatever that point is. Well, there's another way that we could describe points in the plane. We could think of the points as being, we could think of the points as being a distance from the origin and some angle that is made with the positive x-axis. And if we do that, then we're going to name, instead of x and y, we're going to name this distance r for radius, and we're going to name this angle theta. And so the point, instead of being xy, we now could describe as r. Let me do it over here. We could describe the point as r theta, meaning take some distance and rotate it through some angle, okay? Well, how do we translate between the two systems? Well, let's think about this for a second. I've got a y coordinate, I've got an x coordinate. Now, it seems to me that I can use some right triangle trigonometry here. In fact, r squared is x squared plus y squared. And I know that cosine theta is adjacent over hypotenuse. So I can say that x is r cosine theta. I know that sine theta is opposite over hypotenuse. So y is r sine theta. And then if I wanted to go back the other way, right, I've got r squared is x squared plus y squared. Theta, you think of tangent theta as opposite over adjacent, y over x. And so these give us a way of converting between the two coordinate systems. Let's start by plotting. So what I have here are this polar coordinate system. My first point is 2 pi thirds. So if we look at how this is oriented, right, this would be the positive x-axis. That would be like theta equals 0. Up here, the y-axis, that would be pi halves. Here's pi fourths. Okay. And so these are just the standard angles. So this is actually pi sixths. Let's see. That's pi thirds. Okay. So 2 pi thirds. So here's 2. You rotate pi thirds. That's the point, 2 pi thirds. 1 negative pi fourths. Well, here's 1. And then the negative tells me to rotate clockwise. So there's the point 1 negative pi fourths. 2 7 pi sixths. Well, here's 2. I'm going to rotate there's 6 pi sixths, 7 pi sixths. Okay. And then we have a -2. So instead of starting here at theta equals 0, I'm going to start out here at theta equals pi. There's -2. And then I'm going to rotate in the positive or the counterclockwise direction. So if I rotate 2 pi thirds, that takes me to there. So that's the point. -2, 2 pi thirds. And it's also worth noting that in Cartesian coordinates, like if I give you the point 3, 4, there's only one way to describe that point. But in polar coordinates, there's many ways, multiple ways to describe a point. Like the point 2 pi thirds, I could also call that 2, and then negative, and then a certain number of radians. Or I could start at -2 and work positive or negative direction. So there's lots of ways to articulate these points. Let's convert, shall we? So the first one, and again, we're in rectangular points. So we have X and Y. So first, we're going to need to get R. Well, R squared is X squared plus Y squared. And so that's going to be 32. So R is 4 square root of 2. And then what's theta going to be? Well, I know that tangent theta is -4 over 4, which is -1. But I want to be careful because I need to think about what quadrant I'm in, right? I'm down here in quadrant 4. So my theta is going to be either -pi4, or I could call it 7 pi4, depending on which way I want to rotate, okay? And so that point is the point 4 root 2. I'll keep things positive. Okay. Let's try another one. Let's look at -2, comma, root 3. All right, well, R squared is going to be -2 squared plus root 3 squared. So that's 4 plus 3, 7. So R square root of 7. And then tangent theta is root 3 over -2. And so we're in which quadrant? Well, -2 root 3. So we're in quadrant 2, right? So if I were to look at, right, you need to think about what inverse tangent does for you, okay? So inverse tangent of sorry, I'm just plugging this into my calculator real quick. Is -0.71, we'll call it, which is this angle here. But what we really want, what we really want is this angle, okay? So if I take 3.14 roughly, right, because this is also vertical angles, right? Minus 0.71, that'll give me what? 2.43. And so this point is the square root of 7, comma, 2.43. And again, it's in radians, okay? All right, let's try one more. -7, comma, 0. So that's over here on the negative x-axis, right? And so my radius is 7, and my angle, well, if I start at 0, my angle would be pi. And so I could call that point 7, comma, pi. What's also interesting is I could call it -7, comma, 0. But remember, this is not xy. This is a radius starting at -7 and no angle. Okay. All right, well, let's go the other way as well, from polar to rectangular. So for A, we've got the point 3 and then 11 pi sixths. Well, we know what R is, but we need X and Y. So X, we know, is R cosine theta. And cosine of 11 pi sixths is going to be √3/2. Right, quadrant 4. And Y is R sine theta, which is going to be 3 times -1/2. So in Cartesian coordinates, we have this point, which again makes sense because you think about this is 3 and we're rotating 11 pi sixths. Okay. Here comes B. -1, comma, pi. Well, X is -1 cosine theta, which is 1. Y is -1 sine theta, which is 0. Again, -1 pi takes us there. So that's the point 1, 0. Okay. And one more. How about we have the point 5. Oops. -15 pi fourths. So X is 5 cosine of -15 pi fourths. And then let's think about what -15 pi fourths is. Well, if I'm starting at 5, I'm going in the negative direction. Well, 8 pi fourths is going to take me around the circle once. 16 pi fourths is going to take me twice. So 15 pi is just pi fourths short of 2 pi or 4 pi. So, come back. So I can call this 5 and then cosine pi fourths. So you get 5√2/2. And just by what we know about the unit circle, that means Y is going to be the same. So that point is 5√2/2, 5√2/2. Okay. All right. Let's look at going from polar from polar to rectangular equations. Okay. From rectangular to polar equations. So the first one, x squared plus y squared equals 49. Well, x squared plus y squared is r squared. And so we could just call this r equals 7. And isn't a circle of constant radius, right, independent of the angle? If you have a constant radius, you have a circle. And that's what we have, r equals 7. How about x equals 4? Well, we know that x is r cosine theta, which means r would be 4 over cosine theta. So r is 4 secant theta. Okay. Which should also make sense because if you've got a vertical line, right, that radius, that distance from the origin should be going off to infinity, right? As your angle increases. All right. And then how about this one? X squared minus 4x plus y squared equals 5. Well, I know that x squared plus y squared is r squared. I know that x is r cosine theta. Okay. So there we go. All right. Let's go the other way. Polar to rectangular. Let's say we have r equals 3. Well, that means that r squared is equal to 9. And why did I use r squared? Oh, because that's how I relate r to x and y. It's through r squared. And so I get a circle of radius 3 centered at the origin. All right, and then the last one, r equals 3 cosine theta. So I want to be careful here because I don't have any r squareds. I also don't have an r cosine, because if I had an r cosine, I know that would be x. So what I can do is multiply both sides by r. Nothing wrong with that. It's perfectly legal. And then when I do that, I get x squared plus y squared equals 3x. And there we have it. Okay. All right. So that is just a quick review of what polar coordinates are and how to convert. Next lecture, what we're going to do is we're going to talk about what certain polar curves look like. We're going to do that through Desmos, do some investigation. Some of them should be familiar. A few you may have forgotten, but that's what we're going to do next. So hold on tight, and I will see you in the next lecture. Happy study.